Okay, here's the second video for the 2012 AP test. This is question number 2. We've got the region R. It's in the first quadrant, bounded by the two functions, and we need to find the area of R. So at close first inspection, I noticed that a dx slicing of this, so making rectangles vertically, will work fine, but I'm going to have to break it up into two separate rectangles because I have two functions defining the top of the interval. My other option is to do dy slices, and then I have to integrate from right minus left to make my rectangles sideways, and that'll be nice because then it's always the one function above the other one. They both have downsides. The dy slicing, I have to put things in terms of dy, and that's slightly annoying. I think I'll just do it as a dx, just keep it simple. So the first thing I'm going to need to do is I'm going to need to find out what this point is right here. And I did that on my calculator already. And I'm going to label that the point AB. And it is the point, where did it go? It is 3.639. Nope, that's not true. 3.693 and 4414. That's the x. I'm going to find the y. I may not need it, but I'm here. And that's 1.3065586. Okay. So now that I've found that, part A should be simple enough. I'm going to integrate from 1 to A of, that's the natural log function. And then I'm going to add to that the integral from A to 1, 2, 3, 4, looks like 5 of the other function, which is 5 minus x. And so that's what I'm going to do. And the first one in my, okay, so I'm going to simply use my calculator. And so I'm going to go to Math 9. Hold on a second. Get out of the graph. Math 9, y1, because that's where I've got natural log stored. From x, comma, from 1, 2, and then I got to type in 3.69, etc. Or, since it's already stored in my calculator, I can just hit x again. And I get an answer for the first part of 2.132256 plus, now I need to do it again, and it'll be just as easy to just do Math 9 again because I got to change too much in that first integrand. So I need to go to variables, y variables, function 2, comma x, comma, from A, which is still stored in my calculator as x, so I can hit x again, to 5. So comma 5. And that gives me 0.85354. So I'm going to add those together, plus 2.132256. And that gives me an answer of 2.9858, etc. There's no units been given, so I don't have any units as an answer. A is done. Part B, the region R is a cross-section of a solid. For the solid, perpendicular to the x-axis is a square. So I'm going to slice it up vertically because it says perpendicular to the x-axis. So pay attention to that. Sometimes it's y-axis. It says write but do not evaluate an expression that gives you this volume. So once again, I'm going to need to break this into two parts because at least for this section, when I cut it in and make my squares, the height of the square, the side length of the square, is determined by simply the function. And then over here, it'll be the other function. So I should end up getting very similar integrals to the last one. from 1 to A of now I make the slice, I pull it out and lay down the square, and this distance from here to here is this distance, and that's simply going to be natural log of x minus 0 or natural log of x. So the area is going to be the natural log of x squared dx plus from a to 5 of pretty much the exact same thing, just the different function. My vertical slice now makes a height from here to here, and so now that's the other function. So 5 minus x, the quantity squared dx. And that's it. Part C, a horizontal line y equals k divides the region into interval into two regions. So I've sort of scribbled over my paper here, which is kind of a mistake. Alright, oh, that's a really big eraser. Alright, I'm not going to risk it. So what they're saying is we got to draw a line y equals k. So I'm just going to sketch a horizontal line. Clearly it's bad. Y equals k. And we want it to divide R into two equal regions. So the nice thing about them being equal is then that means the area of each of those regions would be equal. So I should be able to write an integral equation equaling another integral equation and be done. This looks like a pain to do, dx, but if we go back to looking dy, now it becomes pretty simple. Because now I just want to find when the area below the line is equal to the area above the line. And so now I need to look at my equations for dy, so I got to rearrange them. So y equals ln x becomes y equals, well actually I'm not doing inverse, I'm just switching them. So it becomes simply x equals e to the y and this equation becomes simply solve for x, so I get x equals 5 minus y. Okay, so now I just need to write an integral from the bottom of the interval up to the top, which is k. So 0 to k of right minus left, so 5 minus y minus e to the y dy. So that area below has to equal the area above. So from k all the way up to the top, which is a good thing I wrote down my y value of that point. If not, I would have had to go find it again, or maybe made a mistake and just did the x value. 655. And then that would be, again, right minus left, so the same exact integrand as the first one. I think that's it, so I'm going to take a look again at the question. The horizontal line divides it into right, but do not solve an equation that involves one or more integrals where k is an unknown. I think we're done. So let's see if we can compare it to the answers here. And so here they are. Alright, let me get this out of the way. So they found the points A, B, 3.69 and 1.30. Let's see if that's what we got. Yep. So they did it two different ways, just like us. They talked, well, we talked about it. So this way they did it as a dy, so they went right to left. Or you could do it we did and break it up into two, get 2.986, which, get that out of the way, 2.986. So you got your points, one for the integrand, either one that you do, one for the limits, so going to the right locations, and then one for your answer. Alright, part B, that was where we wrote for the base of the solid. And the volume from 1 to a of the natural log squared. Yep, that's exactly what we put. 2 points for the integrand, so making a mistake with one small mistake, you could still get a point. And then 1 for the expression for the total volume. So let's see what we wrote. I guess I didn't say volume equals, but it said expression, so I think we're good. And then part C, gotta find that document again. From 0 to k of the integrand equals, what did they do here? Oh, they did it a different way. I don't know that I like their way. What did they do? Okay, I see. What they did was they said from 0 to k, so that bottom half has to equal half of the total. And since we'd already found the total up in part A, they just set it equal to that. I can't see how they could count off for what I've done, because this would do the same thing. But in retrospect, it does seem that that would have been a good way to do this. Okay. What are we at? 11 minutes. Let's quickly check out the scoring for this one, or the discussion of how well they did. I think it's this. Nope. That's the questions themselves. We want this one. Alright, so question 2. Students were given the graph, etc., etc. We know that. How well did we do? Average score was 3.09, not bad, out of 9 points. Difficult for many who attempted to always keep it in terms of x instead of going to y. So anyway, 3.09 was the average. And hopefully you did much better than that. Okay, that's the end of this video. We'll get question 3 next.